In math, we use lines of symmetry to bisect shapes into identical mirrored halves. The word bisect means to cut something in half. For example, a heart, a star, and some letters of the alphabet can be bisected with lines of symmetry so that the opposing sides are mirror images of each other. In fact, many of the man-made structures in the world around us are symmetrical and have lines of symmetry, like the Eiffel Tower and the Gateway Arch. Similar to the Gateway Arch, a parabola is another shape that has a line of symmetry that divides it into equal mirrored halves. Because this line of symmetry is perfectly vertical on the Cartesian plane, we refer to it as the axis of symmetry. We can use an equation to represent such an axis. Recall that vertical lines can be plotted on the Cartesian plane using an equation. Whenever the line intersects the x-axis, we write x equals that value. For example, a vertical line occurring 2 units to the left of the y-axis can be expressed using the equation x equals -2, because it intersects the x-axis at -2, and because all points on that vertical line have an x-coordinate of -2. Using this information, we know that we can find the equation of an axis of symmetry by determining the x-coordinate of the vertex of the parabola. Consider this parabola, which has a vertex at the point 3, 2. Because the x value of the vertex is 3, we know that the parabola's axis of symmetry must occur along the vertical line x equals 3. The y-coordinate of the vertex has no bearing on the equation of the axis of symmetry, because x equals 3 would work for any parabola with x equals 3 as the axis of symmetry, no matter the height. So we can determine the equation of a parabola's axis of symmetry by determining the x-coordinate of the vertex. How can we accomplish this? There are 2 common formats for expressing the equation of a parabola, so there are 2 common methods for finding the x-coordinate of the vertex. The first format is called standard form, in which the parabola is written as y equals ax squared plus bx plus c, where a, b, and c are constants. When a parabola is expressed in standard form, the x-coordinate of the vertex can be found using the simple formula x equals -b over 2a. Let's try it out with an example. Find the equation of the axis of symmetry of the parabola y equals 2x squared plus 4x minus 1. Since this parabola is already in standard form with descending terms, we can plug a and b into our formula. So x equals -b over 2a becomes x equals -4 over 2 times 2, which simplifies to -1. We know that -1 is the x-coordinate of this parabola's vertex. Because of this, the axis of symmetry occurs along the line x equals -1, as shown here. Let's discuss the second method for finding the x-coordinate of the vertex. If a parabola's equation is not in standard form, it may instead be written in vertex form, y equals a times x minus h squared plus k. Here, a is a coefficient determining the wideness of the parabola. More importantly, though, h and k are constants which tell us the exact location of the vertex. H provides the x-coordinate while k provides the y-coordinate. Of course, when it comes to finding the axis of symmetry, we are concerned only with h, which gives us the x value of the vertex. Notice the equation is x minus h. In math, a negative sign means the opposite. So when finding the x-coordinate of the vertex, change the sign of h in the equation. Let's try this method now with an example. Find the axis of symmetry for the parabola y equals 1/4 times x minus 5 squared plus 3. This parabola's equation is written in vertex form, and we can quickly identify h as the constant inside the squared parentheses, x minus 5. Remember to change the sign to find h, so h equals 5. We now know that the vertex's x-coordinate is 5, and therefore the axis of symmetry occurs along the vertical line x equals 5. Let's practice both methods with a couple more examples. Find the axis of symmetry for the parabola y equals -8x minus 10 minus x squared. The equation of this parabola is neither written in standard form nor vertex form, but we can easily change it to standard form by bringing that -x squared term to the front. Now the terms are in descending order, and we can use the formula x equals -b over 2a to get the x-coordinate of the vertex. Here, b equals -8 and a equals -1. The vertex of this parabola has an x value of -4, indicating that the axis of symmetry is located along the vertical line x equals -4. What about the parabola y equals x plus 2 squared minus 1? Where does its axis of symmetry lie? We can identify that this equation is written in vertex form because of the distinctive squared binomial. Now the question is, what is h? Remember, in vertex form, h is inside the parentheses and follows the x variable. Remember to change the sign to find the x-coordinate of the vertex, so h equals -2. We now know the axis of symmetry is the vertical line x equals -2. As we have seen, if a parabola is or can be written in standard form, you can use the formula x equals -b over 2a to find the axis of symmetry. If the parabola is in vertex form, then the axis of symmetry is x equals h, but don't forget to change the sign. I hope that this video is helpful. Thanks for watching and happy studying.